Bonsoir Montréal-Python. Good evening Montreal-Python. Welcome to our 78th meeting. Bienvenue à notre 70e rencontre. On vous invite à vous joindre à nous sur Slack. mtlpi.org/fr/slackin. On est dans le canal Meeting. We invite you all to join us on Slack. mtlpi.org/fr/slackin. And we are in the meeting channel. We're going to have 3 presentations tonight. And we're going to have a yoga session because with all this lockdown and pandemic, we get a little bit less flexible. So we're going to stretch and make sure that we do some exercise even while we're confined. And we're also going to have a social time with Online Town. So stay with us after the presentations and we're going to get everybody's faces together and hopefully share some relaxing drinks and stories together. Alors, tout le monde, on va avoir 3 présentations ce soir. On va avoir une séance de yoga pour s'étirer et se délier les muscles un peu. Et puis, après les présentations, on va avoir une session sociale sur Online Town, presque comme quand on était au Benelux, à boire une bière ensemble. On va voir tous les visages de tout le monde. On peut faire des petits groupes et avoir des discussions. There's something important I have to say tonight before we start. 2 things, actually. First is that we have a code of conduct at Montreal-Python. If you haven't seen it, it's on our About page, mtlpi.org, and go on the About page. It basically says that we want you to be all excellent between one and another. If there's something that is not excellent for you, please find me, Yannick, or Yamlal Gotham on Slack and tell us, and we're going to do our best to resolve that situation right away. The other thing is that everyone is welcome at Montreal-Python. No matter what your language is, what the color of your skin is, sexual orientation, religion, it doesn't matter. You're all welcome. And furthermore, talks about inclusions and your experience if you're part of a minority in the tech community in Montreal or elsewhere. These don't have to be technical, and please come and share with us. You will see our email address in the slides, and we would like to give you a place to share these stories. So please contact us and share with us these stories. Alors, 2 petites choses que je veux mentionner avant qu'on commence, c'est qu'on a un code de conduite à Montréal-Python et vous pouvez le trouver sur notre site web mtlpi.org sur la page à propos. En gros, ça dit qu'on veut être excellent les uns envers les autres. Et puis, s'il y a quelque chose dans la rencontre de ce soir qui ne semble pas être excellent, trouvez-moi, Yannick, ou Yamlal Gotham sur Slack et dites-nous-le. Et puis, on va faire de notre mieux pour résoudre la situation. Et la deuxième chose que je veux mentionner, c'est que tout le monde est bienvenu à Montréal-Python. Peu importe votre langage, la couleur de votre peau, votre religion, orientation sexuelle, vous êtes bienvenus. Et plus encore, on veut vous donner une occasion pour partager vos expériences en termes de diversité, d'être membre d'une minorité. Ces présentations-là n'ont pas besoin d'être techniques et si vous voulez partager avec nous votre expérience en tant que personne d'une minorité dans la communauté technique, eh bien, contactez-nous. Notre courriel est dans les slides et on va se faire plaisir de vous donner un endroit pour partager ces expériences-là. Et donc, sans plus attendre, je vais passer la parole à Van qui va nous parler d'automatisation SSH avec Paramiko. Van, are you ready?
Yes, thanks, Yannick. I'm ready.
Excellent. So I pass it to you. Here's Van.
Okay. Yeah, thanks so much for Yannick. So today I would like to talk about the Paramiko. In this confusing time, we usually work at home and try to control the machine remotely. Standardly, I use SSH and do the command line on server. However, we have a better way to do that by using Python. Example, I enter my server, I check for the requirement package, I install something, and I can set the permission folder, everything automatically from my simple applications home. Now let me share the screen. Wait a second. Okay. Just please wait me just 5 seconds.
While we're waiting for Van, if you haven't done so yet, you can join us on Slack, mtlpi.org/fr/slackin. And here is Van again.
Oh yeah.
Welcome back.
Sorry. Yeah. So thanks. It's just some problem with Google Chrome. So actually, what is Paramiko? Is a library that help us to use SSH protocol to connect to the virtual machine or server cluster everywhere we want. The nice thing of this library is it can be used on 3 platforms: Mac, Windows, Linux. Every platform is okay. It can also have a nice feature that they have a mini SSH server inside. So if we need to do something like more complex or very customized on our server, we can also use it to implement it. In this example, I also use a library called Paramiko and SCP. SCP actually a small utility that use the function of Paramiko to send and retrieve data from the from my server. So let's go to the practical part. It's very simple to use it. So if we connect that, we need a username or password or SSH key. But in this demonstration, for the simplicity, I use the username password. It's better. Otherwise, we have this complex code to set up, to copy, to upload the keys to the server. After the connection is established, we can execute the command. I will go to the demonstration application later. Here is a summary. So we can, as we get the command, it will return whatever the usual command returns. For example, the error, the output, whatever. And it also can help us to, like, if we don't need to use something complex, we can use the FTP client to get some file back. For example, I do some analysis on the server, and at the end of the day, I just call a function to grab the log and the graph back to my local computer. So now let's move to the demonstration. Okay, this one here. In this demo, I make a simple class that connect to my VMware machine, and it will do some things simple, like list the content of the directory, uploading file. Actually, we upload the whole directory to that Ubuntu on my VMware workstation. So let's walk through the code. It's exactly what I showed before. First, we need information, username, passwords, and we connect it. We establish the SCP. This is because I want to do it in this way. It's nicely. For the one of the problem with this, we always have to check the error. But in the example, I check not all the errors, just some, because otherwise it would be too complex. When we connect to that, the server can have problem. I mean, the internet at home has problem, everything. Okay, that is for the sake of internet. I have to do things, try and accept in the loop while. So now let's go back to how it works. Okay, I will comment now this one. and run it interactively on the console. So first, oh wow, luckily it connects successfully to the server. I tried to run another command on my local server. On that machine, it doesn't have Python installed, so it will return something on the screen for us. That is a nice thing that we run it remotely, but we can see it. If there's something doesn't work at the server, so you can see the standard output from that command, bash Python command not found. So it means that my VMware station doesn't have the Python installed. One of the most common uses of Paramiko is to uploading the files, documents, the data set, or whatever you can think of to the server. I put, for example, here, I put the whole directory of this example to the server, put in the home demo. Okay, here we have to make the demo folder on the remote server, otherwise it doesn't work. Here, I will try to do it now. You see, it's really cool that it has a feature to show the progress of uploading. Here, okay, this thing is from the Git repository. It helps because when, for example, if you upload like the files 1 GB from the your working computer to remote server, you can check what is going on in real time. So now let me check if everything is okay by running the 3 command on that uploaded folder. Okay, error. Yeah, this is the output. It looks ugly. However, thanks for the logging, I already make it nicely here. You can see. So 3 demo and here. Okay. That's all for my part. This is very simple utility. However, it's quite powerful to do the job. It can save a lot of time and headaches when we have to do something complex, but didn't want to constantly connect to the server. Okay, that's all. Yeah, thanks. Now I will
Thank you,
turn
Van.
back to Yannick.
Thank you. We have time to answer a couple of questions, and I will let Yamlal Gotham be our moderator for the questions. So everyone, you can ask your questions on Slack or in the YouTube comments. Donc tout le monde, on a le temps pour quelques questions et vous pouvez poser vos questions sur Slack ou en commentaire sur YouTube. Et Yamlal, je vois que ton micro est muté. Ça pourrait poser problème. It looks like your talk was perfectly clear and that people don't have any questions.
Yeah.
But I have one. So let's see. So you talked a little bit about key distribution. So because using passwords hard-coded in the code has obvious problems. So can you talk a little bit more about how you would do the key distribution if you have let's say a couple dozen servers and you want to make sure that you can connect to them as their provision? Like, how would that work in order to have
that is
adequate automation?
Yeah, thanks, Jan. That is a standard use case. Okay, first we just do it like normally. We do it by logging remotely. We have to generate a key, but in this case there is a utility in the library that we can load the SSH key, and instead of connect using the username password hard code like that, a simple example, we just put there. For detail how to that function work, you can check the library. But anyway, it's well supported for that function.
Excellent. And how do you get the key on the server? Like, so because that part has to be automated as well.
Yes, you can automate it, that part too.
Okay, and Paramiko supports it, or you do it with your provisioning system?
Well, we have to do it by, okay, there are two ways. We can do it manually. Manually everybody can do it. Secondly, we can, we can use it, let me see. Yeah, usually I do it manually because I have the key on my computer, but I have another example that everything is setting up automatically. It's not that complex, but it's not recommended, especially with the key, because, well, if there are some error when we transferring the keys, and for the first initial step, it is hard to track. So it's better that you put the key there and then you connect it later with your keys at the local computer.
Very good. Excellent. Gautam, how are we doing on questions? Anything on Slack or on YouTube?
So far, we don't have any question.
Okay, I think it's it's pretty clear and simple to use. So happy that people do not need any extra things.
Perfect. And I assume you'll be staying with us for a little longer. So if anyone has other questions, feel free to ask on Slack in channel meeting.
Yeah.
Thank you.
Sure. So yeah, thanks. So.
Okay, and now for something completely different, I'm going to invite John. And John, comment ça va?
Ouais, ça va très bien. Oui, allô?
Yes, oui, ça va super. John est un technologiste, un pitonneur et aussi un passionné de yoga, et puis il va nous aider à nous délier les muscles en nous enseignant des poses de base de yoga. John, je te passe la parole.
D'accord. Je ne sais pas si vous me voyez bien. Est-ce que vous m'entendez bien aussi?
On te voit bien. Il y a un peu d'éclairage là en contre-jour, mais on te voit bien et on t'entend très bien. Je vais laisser Gautam être le modérateur pour s'il y a des questions de vive voix pendant que tu t'éloignes un peu de ton ordinateur.
OK. OK, je vais comme... Oui, allô tout le monde. Moi, c'est John, un passionné de yoga. Je vais vous présenter une séance d'asanas pendant quelques minutes. Bon, asana, c'est une partie de Hatha Yoga qui a été vulgarisée par Patanjali à un certain moment. C'est un membre de yoga. Et pour aujourd'hui, dans les asanas, je vais vous présenter quatre mouvements. Et parce que avec le asana, ça permet de travailler la flexibilité de ton corps. Et ensuite, ça aide aussi à l'équilibre. Et ensuite, il y a d'autres mouvements qui aident aussi à la respiration pour préparer la méditation, tout ça. Et si vous n'entendez pas très bien, vous pouvez me dire si le niveau est correct. OK. Mais maintenant, on va commencer avec les mouvements de base, les étirements. Est-ce qu'il y a une possibilité que je peux vous voir? Ça va nous aider aussi dans la séance.
Malheureusement, John, on n'a pas cette possibilité-là. On a seulement les présentateurs avec nous. Donc, les gens qui nous suivent sur YouTube ne partagent pas leur caméra avec nous.
Ah, OK. Ça veut dire que je ne peux pas voir les mouvements s'il y a quelque chose qui... OK, je pensais que j'allais voir.
Malheureusement, non.
D'accord. OK. Je vais commencer avec les étirements. On va commencer avec les étirements. Et ensuite, on va commencer avec les postures d'équilibre par la suite. Parce que l'important dans les mouvements, c'est la respiration, la façon que vous respirez dans le mouvement. Par exemple, quand vous baissez, vous expirez, et quand vous montez, vous inspirez dans le mouvement. On va commencer. 1, 2, 3, 4. Je suis en train d'inspirer. Et maintenant, je baisse. Je suis en train d'expirer. Je reste dans le mouvement. Je reste dans le mouvement pendant 5 secondes ou plus. Ça dépend. Et ensuite, je remonte. 1, 2, 3, 4. Et je descends. Ça, c'est un mouvement. Et ensuite, je continue avec un autre mouvement. Je lève sur mes genoux et l'autre pied est étiré vers la gauche. Et je regarde mes doigts. 1, 2, 3, 4. J'inspire. Et ensuite, je descends. Et maintenant, on a fini avec cette partie-là. Maintenant, on va faire l'autre côté. J'allonge. J'inspire. Expire. Je descends lentement. Parce que dans le yoga, il n'y a pas de compétition. C'est juste à ton rythme. On remonte doucement. On descend. Et on répète le mouvement. C'est toujours bon de répéter le mouvement 3 fois. Un, 2, 3, 4. Je descends doucement. Je remonte. Doucement. Je vais faire le mouvement 2 fois. Après, je vais passer avec un autre mouvement. On regarde complètement au bout du doigt. On descend doucement. Maintenant, on va passer avec un autre mouvement. Et après chaque mouvement, c'est toujours important de prendre quelques secondes pour la relaxation. On s'allonge sur le dos. Mais quand on descend sur le côté droit et ensuite on couche sur le dos. On détend complètement notre corps. On inspire et on expire. On inspire et on expire. On inspire. On expire. Okay. Maintenant, on va passer avec le mouvement de cobra. C'est comme exactement le cobra. Mais le ventre va être par terre et ensuite, on va soulever. Ça va travailler entre Bon, notre colonne vertébrale, au début, face au sol pendant quelques secondes. Et ensuite, on met la main à côté, environ 90 degrés. Et on va lever doucement avec la tête. Et on va plier la colonne vertébrale jusqu'en arrière. On descend. Et quand on fait le mouvement, on garde le souffle. Quand on monte, on garde le souffle. Et quand on descend, on expire. On va aller pour une deuxième fois. On descend. Ok, maintenant on tourne. Ce qui est intéressant dans les mouvements aussi, quand tu fais un mouvement, tu fais l'inverse. Par exemple, si tu travailles le muscle qui est en avant, tu travailles le contraire. Ça aide exactement à la flexibilité. Maintenant, on va travailler le charrue. On couche sur le dos. Dans ce mouvement-là, on inspire et on expire. On fait les deux. Doucement. Et on descend. Quand on descend doucement. On descend. Quand on arrive, on met le pied au sol et on allonge le pied. On allonge les deux pieds maintenant. On continue à expirer normalement. On inspire et on expire. On va essayer une deuxième fois, mouvement. Pour commencer, on met les pieds au sol. On met les mains à côté. On prend un peu d'appui sur les mains. Si on ne peut pas monter comme ça, on peut utiliser les mains pour nous élancer un petit peu. C'est ça. On inspire et on expire. Au descendre, on plie un petit peu les genoux. Au descendre, on plie un petit peu les genoux avec les pieds. Direction en arrière. On descend doucement. L'important, c'est aller doucement. Vous n'êtes pas obligé d'arriver jusque-là. Vous pouvez juste arriver au niveau que vous êtes capable. Tiens. Maintenant, on va aller avec un autre mouvement. On va faire le mouvement l'oiseau, qui est un mouvement d'équilibre. On va faire deux mouvements d'équilibre. Pour l'oiseau, c'est comme un oiseau. Regardez devant dans un point fixe, directement en avant. Et ensuite, vous étirez. On va aller faire l'autre côté. Dans ce mouvement-là, on inspire et on expire. C'est intéressant. On enchaîne avec un autre mouvement d'équilibre qui s'appelle le corbeau. Je pense que vous me voyez mieux. C'est les deux mains au sol, jambes et les pieds et les genoux sont écartés à de 30 cm. Et ensuite, on tourne les coudes vers l'extérieur. On prend un peu l'appui sur les coudes avec les genoux. On avance vers l'avant jusqu'à ce qu'on sent que notre poids du corps est sur les poignets. On peut rester longtemps, on peut rester pendant 5 minutes. C'est un mouvement vraiment qui est très bénéfique pour notre corps. Si on a des problèmes d'équilibre, et si aussi on a des problèmes au niveau des poignets, et ça résout plein de problèmes. On va essayer une deuxième fois. On met les mains au sol, on avance, on lève les pieds. Ça, ok, si vous voyez bien, je tourne, je mets mes mains comme ça, j'avance en avant. Comme ça. Okay. Maintenant, on va prendre quelques secondes pour les relaxations. Dans la relaxation, on fait lâcher prise. On inspire et on expire lentement. On expire lentement. On tourne maintenant. Maintenant, on va faire deux mouvements de torsion qui est le mouvement poisson, on va faire, et ensuite, on va faire le mouvement chandelle. Mais avant ça, on va essayer avec le Siddhasana. Ça aide pour les genoux. C'est un peu, on appelle ça un mudra aussi. C'est comme une posture, comme demi-lotus. Pour faux lotus, on peut faire ça. Et ensuite, tout ça, c'est des variations de lotus. Parce que dans le mouvement, il y a plusieurs variations. peux varier les mouvements, rendre un peu plus compliqués et tout ça. Par exemple, on peut se mettre debout. Parfait. Et pour la position chandelle, je vais être comme ça. On allonge sur le dos. On monte le pied. On regarde les orteils. On descend doucement. Et tout de suite après la chandelle, c'est intéressant de faire le poisson. Le poisson, c'est quand on met en demi-lotus. Ça dépend si on peut faire, on peut être en lotus. On tient les deux doigts, les deux pieds comme ça, et on rentre le dos complètement. On rentre le bassin. Et on regarde complètement en arrière. Et après, on descend, on enlève les pieds. On enlève chaque pied un par un. Pour plus facile. On allonge les pieds. On inspire et on expire. Okay, on va commencer pour une deuxième fois. On va commencer avec la chandelle. Pour la chandelle, on met les mains au sol. Je vais expliquer un peu plus maintenant. On met les mains au sol. On lève les pieds doucement, doucement, jusqu'à ce que les pieds et notre colonne vertébrale soient droits. Quand on arrive ici, on tient le dos. On descend doucement. Maintenant, on fait le poisson. On peut commencer comme ça. On va prendre quelques secondes de relaxation. On inspire et on expire. On inspire et on expire. OK. Et on va s'asseoir. Maintenant, on va s'asseoir en position de lotus. Maintenant, on va descendre complètement. On va faire que nos fronts touchent complètement par terre. On inspire. On expire. On inspire. On expire. On inspire. On expire. Quand vous descendez doucement, lentement, juste avec la respiration. La façon que vous respirez dans le mouvement, c'est ça qui est bénéfique directement avec le mouvement. C'est comme ça fait que non seulement le corps et le mental maîtrisent complètement le mouvement. On va continuer aussi une dernière fois avec la chandelle et le poisson. On descend sur le côté. Et maintenant, on reste sur le dos. On monte. Faites tout de suite le poisson maintenant. On tient les deux orteils. On regarde en arrière. Je descends. J'allonge la pied. Je suis sur le dos. Maintenant, on va finir la séance avec une position de relaxation. On va relaxer pendant quelques minutes. On va faire un petit peu de la visualisation. On oublie notre corps complètement. On réfléchit à rien. On allonge sur le dos. On inspire et on expire. Je descends. Je suis le dos. J'ouvre mes bras. J'inspire et j'expire. Maintenant, on va finir complètement par un massage de la tête jusqu'aux orteils. On va masser les cheveux d'abord. On masse les cheveux, le visage, le cou. Chaleur, c'est intéressant. On masse le cou, on masse les épaules. On masse les épaules. On descend. Quand on arrive dans le ventre, on inspire. On gonfle un peu le ventre. On expire. On rentre le ventre. On inspire. On expire. Maintenant, on continue avec les cuisses, avec les genoux, un peu, juste en dessous les genoux parce qu'on ne mange pas les genoux. La jambe. Et ensuite, avec le pied complet, les orteils. C'est très important de masser bien le pied. On va commencer avec l'autre jambe. On masse le mollet un petit peu. On masse. Les orteils maintenant. OK. Alors, merci.
Merci beaucoup, John. Tu
Ça
peux
me
voir
fait
que
plaisir.
j'ai eu un peu de transpiration
Oui,
en résultat de cette session. C'est plus demandant que ça le semble.
Oui, parce que je pensais que les autres, ben, il y aura les autres personnes qui seront là et ensuite je vais essayer de guider un petit peu. Et je savais pas que c'était complètement théorique aussi. Sinon j'allais mettre plus de bagages. Mais comme ça, je peux toujours préparer, comme donner des liens, un PowerPoint, comme ça pourra vous aider, comme non seulement avec suivre les étapes des mouvements et ensuite comment respirer aussi dans les mouvements et parce que l'essentiel c'est pas de faire les mouvements d'être très flexible. C'est juste aller à ton rythme et ensuite, au fur et à mesure que tu répètes chaque jour quotidiennement, et ensuite, tu vas améliorer.
Excellent. Eh bien, on va poursuivre avec notre programme. Je vais inviter les gens à poser leurs questions sur Slack s'il y a des gens qui ont des questions. Et je vais passer la parole à Carl, donc notre prochain présentateur. Eh bien, merci encore, John. Notre prochain présentateur, Carl Meyer, en direct du Dakota du Sud, un des advisors, c'est quoi le terme pour advisor, j'ai oublié le terme français, de Django, et aussi un software engineer chez Instagram. Il va nous parler de typage en Python. So our next presenter, Carl Meyer, live from South Dakota, one of the technical advisors of the Django project, and also a software engineer at Instagram, is going to share with us his experience typing a large code base. Here's to you, Carl.
Thank you, Yannick, and thank you for the invitation to speak. Thanks, Van and Noel or John for the excellent talks. Hi, everyone, and thanks for having me. I'm Carl Meyer. I work at Instagram as a software engineer in our Python language and runtime team, and I'm going to talk a little bit about type check Python. So if you've seen me around on the internet before, I probably look like this. That's me on the left with my sister prototyping some eyewear designs that never took off. You can find me as Carl Jam almost everywhere on the internet. I've been writing Python since, I guess, before the turn of the millennium, which I think makes me officially old. And for the last 4 years, I've been working at Instagram. And one of the projects I've worked on there is adding type checking to the Instagram server code base, which is all Python. So the plan for the next half hour. First, I'll talk a bit about why you might want to add type annotations to your Python code. Then I'll talk about how Python type annotations and type checking work. And third, a bit about what gradual typing means and why it matters. So why do we want to add type annotations to our Python code? For some people, coming from a static typing background, you might ask a different question. How is Python even usable without static types? But we'll take this question from the point of view of a Python developer who says, Python's been fine for 20 years without type annotations, why do we need them? So in this tiny function, what is items? In Python, we have this idea of duck typing. If it walks like a duck and quacks like a duck, it may as well be a duck. So our duck typing answer to the question, what is items, would be this. Items is some kind of collection that we can iterate over. And the elements in it can be anything that has a value attribute, which itself has an ID attribute. So that's great. It's a very flexible answer that could allow us to reuse this bit of code in different contexts. But code is written once and maintained forever. What about the poor person who has to maintain this, which might be me in 6 months or a year? The expectations placed on the items argument here are entirely implicit. I have to read the whole function, which in a real example might be much longer, in order to put together piece by piece the expectations we have of this argument. And how do I know it's not buggy in the context of my program? What if in some cases item.value can be none? Or maybe I need to change the code and access another attribute of the item. I think every item that I ever pass in here will have this new attribute, but in a larger code base, how do I know? I may have to dig through layers and layers of calls to track down the origin for every collection that is ultimately passed to this method. I've had to do this kind of spelunking through code bases many times, and it's a painful process. With a type annotation, now there's no guessing or splunking. I know. I can go straight to the item class and find out exactly what it looks like. Now, this isn't a new idea, of course. People have been putting this information into doc strings in their Python code for many years because it's obviously useful information to a reader or maintainer of the code. The problem with doc string annotations is that at some point, probably someone will forget to update them and they'll get out of date, at which point they are potentially worse than useless. Whereas this type annotation can be automatically checked for correctness by a type checker, so it will stay up to date. And this can catch bugs. If I modify the item class elsewhere in my code base so that value can now be none, even if I'm not looking at this module, I'll get a type error, a type check error, telling me that this function will break with the new definition of the item class. So one common objection is, I don't need that. I'd catch that with a test, which is great. I love tests. I write many tests. But there's this trope of the dynamic language programmer claiming they don't need static types because they write tests, or conversely, the static typing programmer claiming they don't need tests because the compiler catches their bugs. Both are sort of right, but both are wrong. Let's say this plot represents the entire space of possible inputs to a two-argument function. A single test case is an example. It covers exactly one point in this plot. Typically, we write tests to cover a set of points that we feel or think or hope or maybe even know is representative of the portion of the space that we care about. Maybe if we're really clever, we write some parameterized tests and cover a whole range of inputs that way. Maybe even a quick check style or property-based test using a library like Hypothesis which could allow us to cover an even bigger area with a single test. With type annotations, we can add just a few characters to our function definition and instantly eliminate entire swathes of this area to cover. Annotate that my function takes an int, and instantly, all this area out here for all the possible strings and lists and dictionaries and none is all gone. There's no need to write tests for it. The type checker will error if someone tries to pass me any of those. I can focus my testing effort on ensuring correctness with high granularity in this area where it really matters, where even the best type system can't really ensure correctness. All right, so let's presume that I've convinced you and you want to start type checking your Python. How do you make it happen? To start with a simple example, we have a function here that takes an integer argument and returns an integer. We saw the syntax for the type annotations in the previous example. Now let's use that function a few times. Let's try squaring an integer. Let's try squaring a string. And just for kicks, let's try squaring an integer and then adding the result to a string. To type check this code, we pip install MyPy. MyPy is an open source Python type checker written and maintained by a team at Dropbox. It's by far the most commonly used Python type checker today, so we'll use it for type checking all examples in this talk. So let's run MyPy on our file. We can just run mypy square.py, and we see two errors. Let's look at them more closely. We get one error because we tried to pass a string where an integer was expected, and another error because we tried to add an integer and a string together. And we were alerted to both of those bugs just by running a static analyzer over the code. We didn't have to run the code. We didn't need a test suite that covered every path through the code. So the type checker asks us to annotate our function signatures in order to validate our assumptions about input and output for the function, but in between there's a lot it can infer. For instance, in this class, because it knows that the width and height arguments to the init method are integers, it also knows it can track that type through the assignment, and it knows that a photo object's width and height attributes are integers. And so if in another method we make a mistake, and we claim that our getDimensions method returns a tuple of two strings, the type checker can catch that and tell us, no, that's a tuple of integers we're returning. We can also infer the type of containers. Here we create a list of photos, and without explicitly telling the type checker anything about the type of the list, it knows that trying to add a string to that list is wrong. Now this is the type checker being a bit opinionated by default. In Python, it's of course perfectly legal to have a heterogeneous list with different types in it, but the type checker assumes, based on its inference of the original type, that that's probably not what you intended. If it is what you intended, you would give an explicit annotation where the photos variable is first initialized to tell the type checker what the full list of types is you want to fill that list with. There are, of course, limits to the inference. If we create an empty container, the type checker doesn't know what we intend to put into it, so it asks us to be explicit with the type annotation. We tell the type checker, oh, this attribute is going to be a list of strings, and then it's happening. So that's pretty much the fundamentals of type check Python. To review, mostly you want to annotate your function signatures, the arguments and return values. Occasionally you'll have to annotate a variable, but generally you want to do this only if the type checker asks you to because it can't infer the type. So let's get into some more advanced topics. Sometimes a function can take or return more than one type. The simplest way to address this is with a union type. Union foo bar in the return annotation of this function means the return type could be either a foo or a bar. A really common case of this is a function that can return something or none. So we could say union of foo and none, or that's actually so common that there's a special form for it called optional, where we can say optional foo means the return value could be an instance of the foo class, or it could be a none. So here we have a function that takes an optional integer and returns an optional foo. So let's get ourselves a foo instance and check its ID, and oops, the type checker is not happy with this. Get foo is annotated that it might return none, and we never checked the return value to see if it was not none before we went ahead and accessed the ID attribute. Of course, if it is none, accessing that attribute would be an attribute error at runtime, so the type checker alerts us to that. This illustrates why you should hesitate to use unions, especially for return types. If a function returns a union or an optional, then everyone who calls that function has to check which type they actually got back before they can safely do much with it. But in this case, this is a sad result. We know more about the invariance of this function than MyPy does. We know by inspecting the code that if you give this function an integer, it will always return a foo. And if you give it none, it always returns none. But MyPy doesn't understand this connection between the input and the output. It just knows the function might return none or a foo regardless of what you give it, and it requires you to check the result. So in this case, there's a better way. We can improve this by using the overload decorator from the typing module. It allows for a kind of pattern matching by argument types, similar to overloaded functions in other languages. So we can define an overload for the case where we get a none ID and we return none, another overload for the case where we get an integer and return a foo, and then at last we have the actual function implementation. The overload is only for the type checker. At runtime, only the final implementation is used. That falls out simply from Python's behavior because the third definition of get foo simply overwrites the previous two. So the runtime sees only the final implementation. And that's why the bodies of the two overloads can be simply passed because they'll never be run. Those are just information about the signature for the sake of the type checker. With this definition, now MyPy knows that if we pass in none, we'll get none back. And if we provide an integer ID, MyPy knows the return value is foo, so we don't have to check whether it's none before moving on. This also demonstrates the use of a valuable debugging tool, this reveal type function. It's not really a function in the runtime. You don't have to import it, and it doesn't even exist. If you leave it in your code by accident, you'll get a name error when you run your code. But when you type check your code, MyPy will print out whatever type it infers for the expression you pass to the function. So in this case, MyPy tells us that get foo1, as far as it knows, should return a foo instance. Another similar tool we can use to make our function's type signatures more precise is the type var, or type variable. Here we define a type var whose range of possible types is restricted to string and bytes only. The type variable is like a placeholder for one of several or many possible types. So if we define a concat function, we can use this type variable, any string, in the signature, and the two arguments and the return type here are all any string. And this is different from using a simple union of string and bytes, because the type checker will ensure that at a single call site, both arguments are the same type, and the return value is the same type as the two arguments. So the type variable is constrained to become just one type at any given call site of this function. So what that means is if we try to concatenate a string and a bytes, we get a type check error, which is good because it would be a type error at runtime to do that as well. Of course, trying to pass any other type, like an integer, which isn't string or bytes, will also be a type error. And if we concatenate strings, the type checker knows we return a string, and the same for bytes. Of course, this any string type variable is actually so valuable and so useful, especially in code that needs to straddle both Python 2 and 3, that it's available directly in the typing module. We don't have to define it ourselves. Type variables can also be used to implement generic container classes, which is a slightly more advanced topic that I don't have time to get into here. But effectively, you can define your own container classes like the built-in list and dictionary, etc., and give them generic types. Okay, so that was a lot of information fast. Let's review again. Unions and optionals let you annotate functions that take or return multiple different types. Use these sparingly, especially in return values, since they'll make every caller do more work. Overloads and generics let you tell the type checker in more detail about the invariance respected at runtime by your functions and classes. Compared to using unions, this makes them much more usable for callers. So at this point, somebody's probably thinking, what about my ducks? I like duck typing. In this new type-safe world, how do I write a function that can take any type at all, as long as it has the right methods or attributes? So let's take an example. Let's say I want to define a render function that can take any object at all with the render method and call it. This general pattern might remind you a bit of how many built-in protocols in Python work. The next built-in calls under next on the object, len calls under len, etc. But how can I type annotate this function? I could try annotating the argument as object because all Python types inherit from object, so this will allow me to pass in any object. But this doesn't work because object doesn't have a render method, so the type checker is unhappy with the call to the render method. We can use the any type, which is a sort of escape hatch the type system provides. The any type is compatible with anything. In type system terms, it's sort of like both a top and bottom type, in that it is a subtype of everything and a supertype of everything. Basically, it will never cause a type error. This makes our function type check okay. We're basically opting out of type checking, but it's a pretty sad solution. We've gained no value from applying it. Now the type checker will let us call render with any object, even if it doesn't have a render method. These are the kind of bugs we want our type checker to catch for us. So I mentioned this pattern is similar to Python's built-in protocols like next, len, etc. The typing feature to support this is also called protocol, and we can import it from the typing module. We can define a renderable protocol as a subclass of protocol and give it a render method. We don't have to give an implementation of the method. We're just defining the interface. So we can use a literal ellipsis as the body of the function, which is a convention, or pass works fine as well. Now we annotate our function to accept any renderable. And now we can define some random foo class, and it has no explicit relationship to the renderable protocol. It doesn't subclass renderable, but because it defines a render method with a matching signature, the type checker will consider it a subtype of the renderable protocol. We can pass a foo instance to render, and the type checker is happy. If we try to pass some other object type that doesn't have a render method, we get a type error, just like we want. So we found our duck typing again. You may hear this feature referred to as structural subtyping, in contrast to nominal subtyping. Nominal subtyping is what we have with inheritance. If foo inherits from bar, it is a nominal subtype because we've explicitly named our supertype bar. Protocols are structural subtyping. We determine that foo is a subtype of renderable due to its structure, that is, the methods and attributes it has. So next I'm going to talk about some escape hatches in the Python type system. The type annotations we've looked at so far are typically great for the 85 or 90 or 95% of your code that's pretty ordinary. It follows the expected patterns, doesn't do anything too crazy or unusual. But sometimes you may have some code that's doing something much more dynamic beyond what the type checker is capable of understanding, or like us at Instagram, you may be annotating a very large legacy code base, and you may have a lot of code that was written before types and doesn't really conform to the patterns supported by the type checker. So in order to gradually type that code base, you may need some escape hatches to just tell the type checker to take a walk sometimes. We already saw the first escape hatch, the any type. One case where you might reach for it is implementing some kind of get at or wrapping proxy, where you have no idea what the types of the wrapped object's attributes might be. It's not a great option, since then you lose all type checking on all attributes of the wrapped object, but it is an option, and sometimes it's the best available. As we discussed before, the other annotation we could use here is object. Both object and any mean this could be any Python object, but object is strict and type safe. If you try to access an attribute or call a method on something typed as object, the type checker will complain. You need to explicitly check its type first with isInstance or something. With any, the type checker just lets go, hands off, and assumes you know what you're doing. You'll never get a type error for anything you do with an any. The second escape hatch is the cast function. It basically lets you lie to the type checker. For example, we have an external configuration system that stores JSON structures, and we can query it by key. Since the return JSON structures could have pretty much any shape, our getConfig_var function is reduced to returning any. At least this avoids type errors, but it means we get no type checking on our use of this config data. And often for a particular config key, in practice, we know exactly what shape it will have. So in this case, we can use cast to tell the type checker that it should assume that the value returned for the myconfig key is a dictionary mapping strings to integers, and it will listen to us. Of course, since you're lying to the type checker here, you want to make sure you're really right. If you lie to the type checker and you're wrong, your type checking results will be equally wrong. At runtime, cast is the identity function. It's a no-op. Its only purpose is providing information to the type checker. The third escape hatch is the nuclear option. Just ignore any type error on this line, no matter what the cause. We try to reserve this one for only for working around bugs or limitations of the type checker that we can't work around any other way. One example is that MyPy currently can't handle a property decorator stacked on top of some other decorator, and it will throw a spurious type error on the property line. So we just type ignore that line and try to pair it with an explanatory comment so we know what the problem is that we're ignoring. So if the cast function is a one-off way to lie to the type checker, stub files are how you lie to the type checker at scale. For instance, at Instagram, we use Python and C extensions for performance hotspots. Python syntax is a superset of Python syntax, but the type checker can't read it, and it certainly can't read C code. So here we have some hypothetical fast math compiled module, but the type checker has no idea what's inside that shared library file. That's not cool. If we wrote those functions in C or Python, it's likely because they are called a lot. So we want our call sites to be type checked for correctness. So we can put a fastmath.pyi stub file next to the actual module. It's kind of like a C header file, but for Python. It just gives the function and class signatures and their types for use by the type checker. It's never used at runtime by Python itself. The executable code is in the compiled shared library. So this is what our stub file for the fastmath module might look like. It's Python code, but only the signatures. By convention, we use an ellipsis in place of the function body. Of course, a stub file can also include classes. In this case, we provide a fake implementation of the dunder init method solely because it tells the type checker what attributes this class has and their types. Now the type checker will be able to check the correctness of our usage of this function in class. Okay, so reviewing back to our review, we've added a couple more things. Protocols give us structural subtyping or duck typing that can be validated by the type checker. And we have a number of escape hatches when we need them: any, cast, ignore, and stub files. And there's much more to Python's type system that I don't have time to cover here. Literal types specify that a variable's value must be within a constrained set of literal values, like a fixed set of strings or integers or enum values. Final annotations can declare that a class may not be subclassed, or a method may not be overridden, or an attribute may not be reassigned to. And typedict allows you to give each key of a dictionary a different value type for JSON-like cases where you're treating a dictionary more like a bag of heterogeneous attributes. Okay, so we've talked about why to type check and how you can add useful type annotations to your code. Now, what do we mean by gradual typing and why does it matter? So, strictly speaking, the any type we just looked at is the core of gradual typing. Gradual typing just means that you can type check your program even though not all expressions in your program are fully typed. A static language, like Java, for instance, would require that everything have a known type that the compiler or the type compiler and type checker know about statically. In Python, we don't have that requirement. We can have a program that's partially typed, and we can still type check it and get value from the type annotations we have applied. So anytime you use any, you're already taking advantage of gradual typing. So let's look at a hypothetical code base. Each of these boxes is a Python module. Arrows show dependencies between modules. So we want to introduce type checking into this code base. So if we just turned it on everywhere fully, we'd have type errors everywhere. And that's not even because the code is particularly bad. It's just the nature of turning on type checking for a code base that was never previously type checked. We make assumptions and we rely on invariants that the type checker isn't able to establish. So this isn't going to work. We have too much code and we can't afford to stop the world while we fix thousands of type errors and change all of our code to be type safe. We need a way to introduce type checking incrementally, opting in different bits of code when we're ready to fix the type errors there. So gradual typing is implemented in Python with a very simple rule. Only functions with type annotations in their signature are type checked. Functions without type annotations are effectively ignored. They take any for all their arguments, they return any, and their code body is totally ignored. Nothing within it is type checked at all. This means we can slowly opt in to type checking by starting to annotate a few functions in our code base, fixing the revealed errors as we go. And of course, there's the network effect and the benefits of annotating. You catch type errors when one annotated function calls another annotated function. If you just annotate one module, you'll catch some errors in internal calls within that module, but you won't catch anything in intermodule calls. As you annotate more functions and modules, the number of calls where a type error could be caught increases superlinearly. To maximize the benefits, it's best to start annotating your most used code, the core libraries of your system. Once you've started annotating and fixing type errors, you need to prevent regression or it'll be on the treadmill forever. So you want to set up continuous integration to prevent new type errors from landing in code that you've already typed. MyPy has lots of strictness options, and you can apply options per module in the MyPy config file. So for example, once a module is 100% typed, you can require that no untyped function can be introduced into that module. You can even go further and prohibit the use of the anytype within a module. So that's all great, but there's still a problem. This process of adding type annotations to existing code can be very, very slow. I talked at the beginning about how slow and painful it can be to dig through old code and figure out all of the possible types that could be passed to some function. It turns out that this slow code spelunking is exactly the same work you have to do if you're adding type annotations to old code. Instagram's co-founder, Mike Krieger, was actually the first person to dive in and try annotating one of our biggest core modules at Instagram, and after a week or two, he'd had enough. He suggested that maybe we could try runtime tracing to sample the actual types received and returned by our functions when our code runs, and then use that data to automatically apply draft type annotations. So a couple of us set out to build that, and it worked great. We called it Monkey Type. Monkey Type easily made us an order of magnitude faster at adding types. We have several million lines of Python code at Instagram, and with Monkey Type, we were able to go from 0 to fully annotated in just a couple years. And we also released Monkey Type as open source, so you can use it too. To use Monkey Type, you pip install it. Then you can use Monkey Type run to run any script that exercises your code. For instance, your test suite would be a common choice. And during that run, Monkey Type will record the argument and return value types of every function called while it runs. There are also Python level APIs you can insert into your code to turn on type sampling if you want to sample from production, which is what we do. Once you sample some types, you can run Monkey Type stub and give it a module name, and it will output a stub file showing the signatures it has collected from putting together all the traces it saw for every function and method in the module. You can use this stub file as is with the type checker, or you can run Monkey Type apply, and Monkey Type will actually take those types and apply them directly to your code. Okay, so let's talk just briefly about some things that are coming up in the future for Python typing. One current wart of type annotations in Python is that by default right now they're evaluated at runtime, which means if you have forward references, like a function takes an argument of a type that's defined later in the module, or if you need to refer to a type that would cause an import cycle if you imported it, you have to quote that type annotation as a string, which is kind of ugly. Starting with Python 3.7, this future import will cause the runtime to not even evaluate type annotations, which gets rid of this wart. As with any future import, in some later version of Python, this will become the default behavior. There's also an accepted PEP to reduce the need to import types from the typing module. In Python 3.9, we won't need to import a special capital D dict type anymore. We can just use the built-in dict. Same for list, tuple, etc. And in 3.9, we'll also be getting support for a new, more concise syntax for unions and optionals using the vertical pipe character. And in some future Python version, we'll have a much more expressive way to type the signatures of functions that operate on other functions, so higher order functions such as decorators. A few conclusions from our experience at Instagram with types over the last 3 years or so. First, type check Python is here, it works, and in large code bases at least, it's very useful. It catches real bugs, and it helps make the code more maintainable. Our experience in a code base worked on by hundreds of developers is that even though there have been significant pain points with the tools because they're in early stage, overall developers are much happier working in typed code than previously in untyped code. Monkey type makes annotating existing code bases much easier than it would be otherwise. We are still in the early days of Python type checking, so not everything is smooth sailing yet. There's still problems being worked out, but it's good enough for production use in real systems. And of course, it's actively worked on and it's getting better all the time. A few thanks are in order to the team at Dropbox that creates and maintains MyPy, and to everyone who's contributed to writing and reviewing typing tips. Lastly, as you're working with Type Check Python, there's lots of help available for you. The MyPy documentation is thorough and excellent. The original Python enhancement proposal, PEP 484, is the standards document for how typing in Python should behave. There's real-time support available in the Python typing channel on Gitter. If you run into problems with the typing standard itself, with the reference standard, you can file those on the Python typing repo. Issues with the MyPy type checker, go to its repo. And issues with the standard library type stubs, go to the typeshed repo. And if you're using Monkey Type, you can file issues at Instagram Monkey Type on GitHub. If you'd like to follow up with me afterwards and discuss the many failings of this talk, I'm Carl JM everywhere, except of course on Instagram itself, where I was too late to the game. So feel free to drop me a line and I'm happy to chat. Thank you.
Thank you, Carl. Duke is going to be our moderator for questions, and I remind everyone that they can ask questions directly on YouTube or in Slack, in French or in English. We are going to translate. Alors tout le monde, vous pouvez poser vos questions à Carl sur Slack ou sur YouTube, et puis ça peut être en français ou en anglais. On va s'occuper de la traduction. And I'm going to start with my first question because you mentioned something that I thought was interesting. Did you say several million lines of code at Instagram? Oh, interesting. And a follow-up to that is a lot of people see types from compiled languages where they do provide some performance benefits. But at Instagram, you went with another direction for performance. So do you see performance benefits from types? It is the work that you've done with the other avenues with native C code prior to typing, and how does the two relate?
Yeah, it's a great question. So performance was not the primary motivation for adopting types initially. It was for the developer experience of working in the code. But we do have, we do believe that type information, that we can develop Python in a direction where type information could be used by the compiler to generate more specialized bytecode that can run more efficiently. There's a lot of sort of challenges in the way of that. I mean, the first one is a number of things I talked about in this talk kind of demonstrated ways to lie to the type checker or kind of pretend that something is a type when it may not actually be. As soon as we're using types in compilation, we need to have a much higher level of confidence that the entire type system is sound and doesn't have holes in it, so that we really will see the types we expect at runtime. So there are various ideas for how to address that, but it is something that we're actually currently working on, is seeing if we can make use of the type annotations to get better performance out of our code. Our hope is that we could even eventually replace Python with simply type annotated ordinary Python code and see similar performance from it.
Very good, thank you. I let Duke take over for the other questions. It seems you're muted, Duke. Yeah, indeed. Can you hear him, Carl?
No.
I think I hear you, Duke, but very faintly. Perhaps not. So let me we let you work on your audio setup. I will read the first question while you do that. And the first question was, let me see.
Yeah, okay. I see it in the chat. The question is: are there type annotations for common Python libraries and frameworks? For instance, are there type annotations for the Django framework? So the answer is yes. Many common libraries have type annotations. Some are beginning to add them directly into the code. For the majority that haven't done that, I referenced briefly a repo on GitHub called TypeShed, which is a collection of type stubs for the Python standard library and for many commonly used third-party libraries like NumPy and other libraries. So by using a type checker like MyPy, you'll actually automatically get access to all of the type stubs in TypeShed. And then additionally, there's a standard in PEP 561 for how third-party libraries can bundle type stubs that will be made available to MyPy automatically when you install the library if they don't feel comfortable adding the annotations directly into the code base. Django specifically has type annotations in a separate repo called Django stubs. There's been some discussion on the Django team about potentially adding type annotations to Django itself, but at this point, it's still early enough that the team wants to be conservative and not do that quite yet. But there are stubs available.
Excellent. I think Duke, your microphone seems to be working now.
Yeah. Do you guys hear me now?
Yes.
Yeah. Okay.
Yeah,
cool. Yeah. Okay. Cool. So we're gonna go into the second question. Is say you have a code base that lacks both type annotation and automated tests. Would you rather prioritize adding type annotation first or developing automated tests, or work both at the same time?
Yeah, that is a really, really good question. I think, boy, I mean, if you really forced me to pick one or the other, I think I would prefer tests simply because of the high granularity of what you can verify. But in actual fact, what I would do in that situation is add both at once, because in a certain sense, the workflow is complementary. In order to add tests, you need to take a certain section of the code and understand it, do some research, some digging through the code, really figure out what it does, what it's supposed to do, and then write tests to verify that behavior. And generally in the process of doing that, you'll also come to an understanding of what the expected types are, and so you may as well add those at the same time. So that's how I go about it.
Okay. Thank you for your answer. I have another question here. Could you use single dispatch instead of overload? What would be the pros and cons of what you use?
Yeah.
The two approach. Yeah.
No, you definitely can use single dispatch. So single dispatch, as is implied by the name, only works on a single argument. We don't have multiple dispatch. So for the example I showed in the talk, which only has one argument for simplicity, single dispatch is probably a better and clearer way to implement that. But overloads also support multiple arguments in more complex cases where you wouldn't be able to use single dispatch.
Okay, thank you. I have another question. Does adding type annotation help with Py2 fresh to Py3 migration?
That's a really good question. It's interesting. There's sort of two case studies there that I'm aware of. At Instagram, we first did Py2 to Py3 migration without types, and then we added types, and that worked fairly well for us. I would say some advantages are that we were able to take advantage of the Python 3 native syntax for type annotations immediately. We didn't have to first write our type annotations as comments, as you have to do in Python 2, and then later transform them. And also just the types are simpler once you're on Python 3 because there's many fewer issues of string and bytes and figuring out all the types. Now Dropbox, my understanding is that they chose the other approach of trying to use types as a way to make their Python 2 to 3 migration more rigorous. And I can't really speak to how well it's working for them, although they definitely didn't get to Python 3 as quickly taking that approach because it takes a lot of time to add the type annotations. So I think it can, but it's not necessary.
Okay. So yeah, I think we done with. I don't see any questions. I don't know if Yannick, you want to add something?
I think maybe you covered this and I missed it. What's the your estimate on your type coverage at Instagram, if that's something you can share with us?
We're basically at 100%. It's not full. There's a few stragglers here and there, so I think technically it's 99 point something %, but effectively all of the code is annotated.
Wow, excellent.
I did prepare a very quick live demo of monkey type in action. If you want to see it, it's maybe 3 minutes, but I don't know if we have time for that. I can skip it if you'd rather move on.
Let me double check the time.
By the way, I have another question. I don't know if we have time. If we still have time.
I'm curious about both the question and the live demo, but because we want to make this more interesting than just watching a pre-recorded demonstration, I'm gonna vote for the live demo as briefly and without losing the gist as you can do it.
Sure, I'll do it. I'll do it.
Let's go then. Yep.
Okay, can you share my screen? Is that large enough to read, or do I need to make it even
It's
larger?
really small on my screen.
Okay, well, it's I already upped the font size many times, but let's do it even more.
That's pretty good.
I'm getting to a reasonable size now?
Yeah.
Okay, so very quickly, this is sort of a sample project set up for type checking. And we have a file, inbox.py, which is just, it's some code that's loosely based on some code at Instagram, very loosely, but it's some code to implement a sort of a inbox notification system. And it's partially typed. You can see it has some type annotation, but it's not fully typed. And it actually has some bugs hidden in it. We've used this as a demo at PyCon before, gave people the opportunity to actually try to dig into the code and see if they can find the bugs without types. But then we can run MyPy, and currently with the partially annotated code, MyPy is happy. It doesn't find any bugs. It doesn't find any type errors, but it's not fully annotated. So we have a test suite. So if we run PyTest, okay, it runs some tests. They all pass. That's great. So now we want to use that test suite to to trace the types during the run of the test suite and see what types are passed around. So we'll do that. And the test suite will be somewhat slower, but it will run. And then, as I showed in my talk, we can say monkey type stub inbox, and it generates a full stub for the inbox module with all the type annotations applied that it found by executing the test suite. And then we can do monkey type apply inbox. And now if we do a git diff, we see that it's added a bunch of new type annotations to things that were previously not annotated. And these are all based on types that were seen at runtime in the test suite. And so with those new annotations, if we run MyPy again, the type checker now reveals a number of type bugs that were previously hidden. So that's the demo.
Very good. Very good. Thank you so much, Carl. We unfortunately have to move on to our next presentation, but I will invite people to ask more questions either on YouTube or Slack, and hopefully you will get an opportunity to answer. And if not, you were kind enough to share with us many ways to reach you. So I hope that people will be able to share their questions there. Thank you again.
Thank you.
Okay, and our next presenter, our last for today, before we meet for a social time on Online Town. And if you don't know about Online Town, it's pretty cool. It's a big room where everybody can share their camera, and we can form smaller groups and go from one small group to the other. I don't know how that's going to work with the multiple languages that we speak in this group, and hopefully that's going to be interesting. So our last presenter before this session is going to be Kim, and she's going to be talking about data analysis with pandas. Kim, I pass it to you.
Okay. Okay, do you see my screen with Firefox?
We do not see, we only see the Firefox icon. So I think you should unshare your screen and reshare and select a different window. That should do the trick.
Okay, okay. Is it better now? Do you see my screen?
I do not see it here.
Okay, I will try it again.
Okay, so as we're waiting for Kim to resolve our screen sharing problems, let me mention that, as I just mentioned, and I'm going to say it in French, on va se rencontrer sur Online Town après cette session. Donc, Online Town, c'est un groupe où on peut tout le monde partager nos caméras et se rencontrer en petits groupes. Il y a une salle virtuelle et puis vous pouvez me reconnaître facilement. Je vais être l'avatar chauve dans ce groupe. Je vais essayer de me tenir pas loin de l'abreuvoir ou de l'abreuvoir. Avec un peu de chance, ça va être aussi amusant que se rencontrer au Benelux. Et je vois que Kim ne partage toujours pas son écran. Et j'en profite pour faire une autre annonce. Pour Montréal-Python 79, qui va être la dernière semaine du mois d'août, on a l'intention de faire un code sprint, donc de prendre un logiciel libre, une librairie logiciel libre en Python et de l'améliorer, de réparer des bugs, peut-être faire de la traduction de la documentation. Donc, si vous avez une librairie favorite que vous voudriez nous aider à être le champion de cette librairie-là pour triager les bugs, contactez-nous. On serait intéressé d'entendre, de vous inclure dans notre prochain meeting. Alors, Kim, you are back.
Yeah.
I do not see your screen yet.
Okay. Now do you see my screen?
I do see your screen. So now it's the full screen, except I see the tabs that you're sharing.
Yeah. So do you see my screen now?
Yeah, I see your full screen. So if you just switch to your presentation, yeah, that should be it.
Okay, I will just try to just let me share one screen.
Your screen came back momentarily, but it vanished. Okay, I see it.
Okay, do you see the screen?
Yes.
This one? Do you see this one?
Yes.
The demo.
That's correct. I see an IPython notebook.
Yes. It's the Python. If IPython notebook. So
Perfect.
Okay. So the technical is okay now. Hi everyone. For the closing part, I'm sorry for the technical issue. For the closing part, I have a short sharing about the well-known library of Python, which is very powerful for analyze the data. So it's pandas, and many of you are already familiar with it, but some not. So it's a good time to walk through it. So as you know, pandas provides various tools to read, write the file, and access the data, similar to SQL like select from, where, group by, and so on, and especially the visualization. Today, I'm going to focus on the visualization part, and I prepare a small demo here. So I first start with to include or to import all the necessary library. And with pandas, you can see that we can read the file in many extension format. For example, CSV, DST, or even the DB, the database file. Now I use the CSV file. I read it, and after I read it, and after I read it, so I can, with pandas, I can review my result to verify if it's good or not, if it's already well read or not. So, and after to read the file, I can go further with analyze the file. For example, I can use the F shape. With this one, I can see that my table, there have more than 100,000 rows and with 14 columns. And as well, also I can check if is there any null value in my data. So I can check the null value and make a sum. Okay, and I can also check if is there how many unique value in each column of my data. So I use the df unique. So as you see, if normally if I check the unique, so the summarize will display none very well organized. So it's difficult to compare. So if I sort the value, it will be better. So now it's easy to see it. I can sort ascending or decrease. See? Okay. But if it just only the number is not very interesting. So it's better. I prefer to see something more visualized. So with it, the number of the statistic of the unique number, I can also plot it. Here you can see I can plot. It's depending on your data on the export data. So I can plot it. For example, here if I can plot the data just only non-organized, but I can also sort them and plot them. If I sort and plot, so it's very easy to compare, easy to see. With the plot option, I can plot like bar chart, pie chart, and histogram, and many other kind of chart. And here also we can also, for example, here if we can also with pandas, we can modify the display value as our need. For example, here by default, the label is vertical, it's not horizontal. But we prefer something more easy to see, so we can rotate the label. And I will move on with pandas, we can also group by the data. So we group by, for example, here I group by my data by gender, and then I just only select the age, the column age to analyze. So I plot them. In this case, I use the histogram. And you can see the difference in when I change the parameter in the histogram. For example, if I change the param, you can see that the display will be modified. If you prefer something easy to see, something smoothly, so you can modify the bytes. Or, for example, here, if you don't have the legend, so it will display, but you don't know what is the orange and the blue color. So if you add the legend, so everything will be easy to see. So I will move on. Here I plot two data. I mix two data in one chart. So it's easy to compare. But in the case that I prefer these two data separate, so pandas provide us also an option to do that. So by yield subplot, so with subplot, it defines the number of row and column. So here I have one row and two columns. So with each slot, I can put my visualization in, and I can it's for order to, and I can easy to compare them separately. So just a quick in this sharing, it's just a quick presentation about how useful pandas. So I just go very quickly and not really in detail. So after, for example, after you already have your well visualization, pandas on in Jupyter Notebook, you can also have the export your result into a slide with this instruction. But to execute it, you have to stop Jupyter Notebook and then run this code in CMD in the command line. After you run this code, you can have an HTML file, but in the form of the slide. Here I prepare already. I extract already a slide in HTML. You can see this is the result I already prepared before. For example, your result in Jupyter Notebook, you can extract some data that you like to present and hide some you don't like. For example, this is the result after that. So it's really nice. It's like this one is the one slide, and in one slide you also have the subline. So it's the demo about the presentation. I forgot to say how to convert the Jupyter Notebook into that. Besides, in additional with this code, with the code running in the command line, we have first convert the Jupyter Notebook to the slide deck as well. So in Jupyter Notebook, you have an option view. So toolbar, in toolbar you have the slideshow. And here you have freely option. You have freely to choose the option where you want to slide, where you want to skip, what is the slide and supply. For example, here it's not interesting. I skip the importing. I skip the read the okay. I will keep. I will let them. I will. This one is, for example, the supply. This one is another supply, and so on. And after that, after I already choose on option, I will use it this command line, and I will the slide like that. It's very nice. So and it's all for my short presentation today. And thank you for watching.
Thank you so much, Kim. I'm gonna let Duke be our questions moderator for this one.
Okay. Yeah. Thank you, Kim, for your presentation. Yeah, I'm looking for the question on Slack and YouTube. I don't have it here. Is someone said wonderful for your presentation? Yeah, it's Lucas from Lucas Kavakan. Okay.
Yeah, this is my first presentation, so thank you for watching.
Also, David Leisure said, I had never noticed the slideshow mode. Thank you. Okay, in Slack, I have. Okay, I'm also. Edith said, I did not know about making slides from a Jupyter notebook. Thanks. Okay, looks like we don't have any question, but a lot of comment. So
Excellent. Well, maybe it's time to move on to the next part of our meeting tonight. So thank you again, Kim.
Yeah.
And the next part of our meeting tonight is twofold. One is that we really want you to tell us what you think about this meeting. So please fill that satisfaction survey at this URL bit.ly/np-78-survey. And that's going to help us to figure out what's the right formula for these meetings that we keep changing, and hopefully they keep getting better. And the other thing is that we want you to join us on Online Town. So Online Town is a virtual room where we can have smaller group conversations. I invite you to bring your favorite drink. In my case, it's Chartreuse. I really like it because it's made by these French monks, and they speak French, so a little bit like us. And it's beautiful Python color. Look at this beautiful color. Shows better with this glass. So I'll be bringing my glass of Chartreuse on Online Town. And lastly, I want to say in English what I was saying in French, that for Montreal-Python 79, that's going to be the last week of August, we're going to tag along a code sprint on some free software or open source library in Python, obviously. So maybe we're going to do translation of the code itself, of the messages that the code displayed, the documentation, or we're going to do a bug batch. So if you have a favorite open source library or software in Python, and you would like to be our champion to triage the bugs or the issues that we could be working on, please get in touch with us, because we're really interested to make that part of our next meeting. And that being said, I invite you all to join Online Town. You can stay on Slack and share questions and comments in the chat there. And on that, I will say you bye and see you in 2 months almost. Bye.